Hello math learners! Check this out. We have three different system of linear equations and the topic is all about system of linear equations by graphing method. Now, if you don't know how to solve this system of linear equation by graphing method, well, tune in and finish this video and I will teach you how. But before anything else, hit that subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash, and today we're going to discuss the most essential learning competency based lesson for quarter 1 week 8 of the grade 8 mathematics, which is all about solving system of linear equations by graphing. Now, how do we graph system of linear equation? Remember that in our previous overview about the system of linear equation, the graph has three different scenarios. The first one is parallel lines. The second one is intersecting lines. And the third one is identical lines. Now, if you are having this kind of equations, what you need to do first is to solve them by considering two methods. If you are talking about graphing method, you can choose two ways of graphing. The first one is by the use of the intercept form, which is we will consider the x and the y intercept. The second one is by the use of its slope-intercept form, or the use of the slope and the y-intercept. Okay, now let us do this. We have here x minus y is equal to 3, and the second equation is x plus y is equal to 5. Now, how do we solve this one? Okay, so first what you will do is you will solve the x-intercept and the y-intercept. So when we say x-intercept and y-intercept, that is this one. So this is your x-intercept in which your y is equal to 0. And this is your y-intercept in which your x is equal to 0. Okay, so let's try. If this is 0 for our x, what will happen for our y? So if this is 0, 0 minus y is equal to 3. So that is 0 minus y is equal to 3. 0 minus y is negative y is equal to 3. Divide both sides by negative 1. You will have y is equal to negative 3. Therefore, the y-intercept for our first equation is 0, negative 3, or at 0, negative 3. Now, how about if your y is equal to 0? So, if this is 0, x minus 0 is equal to 3. X minus 0 is x. So, therefore, you will have x minus 0 is equal to 3. So, x is equal to 3. Therefore, your x-intercept is at 3. Okay, so now you are finished in your first equation. So, you can have this in your graph. That is your y-intercept at negative 3. 1, 2, 3. That is here. Okay. And your x-intercept at positive 3. So, that is 1, 2, 3. Okay, that's here. Now, what you can do now is to connect the dots. And this is the graph for your first equation. Now, let us consider the second equation. For our second equation, we need to have the y-intercept as well as the x-intercept. Let's start with the x-intercept. If this will be 0, that is x plus 0 is equal to 5. Then, we can have 5 as our x-intercept. Now, how about if our x is equal to 0? What will be our y? If this is 0 plus y, this will become also 5. So that is here. So therefore, our y-intercept is 5 and our x-intercept is 5. Okay. So for our x-intercept, that is 1, 2, 3, 4, 5. That is here. And our y-intercept is at positive 5. So therefore, that is 1, 2, 3, 4, 5. That is here. Okay. So now, we will connect our dots. And now, this is what our graph for the second equation looks like. As you can see, there is an intersection in this part. And that part is located at 1, 2, 3, 4. That is 4. Okay. That is 4. Our y-coordinate is 1. So, therefore, the solution of our system is at 4, 1. So this is where the two graph or the two equation meet. Now, what does this mean? It means that it has exactly one solution. Therefore, the nature of this graph is consistent and independent. Because as you know in our previous discussion, consistent means it has at least one solution, and independent means it has exactly one solution. Easy, right? Now, let us go to our second example. Okay, math learners, for our second example, we have 3x plus 4y is equal to 8, and the second equation is 15x plus 20y is equal to negative 40. Now, I have already taught you how to use the x and y intercepts in graphing. Now, in this second equation, we will try to solve this using the slope-intercept form. Now, how do we use the slope-intercept form? What you can do is you just transform your equation or equations into its slope-intercept form so that you can determine the value of the slope and its y-intercept. 3x plus 4y is equal to 8. So, what you can do there is that will become 4y is equal to negative 3x plus 8. Okay? So, I just transpose the 3x. Divide both sides by 4. Okay? So, therefore, y is equal to negative 3/4 x plus 2. So, as you know, our y-intercept is located at 2 and our slope is negative 3/4. So, that is positive 2. That is here. Okay? And our slope is negative 3/4. Meaning, if you have a slope that is negative 3, you will go down 3 times and then you run at the right side 4 times. Okay? Or 4 units. So, that is 1, 2, 3. Okay? We go down. And then 1, 2, 3, 4. So, that is 1, 1, 2, 3. We go down from our point. Okay? And then we run 1, 2, 3, 4. So, our point is located at positive 4, negative 1. What you do is you connect the points and you have this graph. Now, let us consider the second equation. We have 15x plus 20y is equal to 40. So, I will transpose the 15, giving me 20y is equal to negative 15x minus 40. I divide both sides by 20. Okay. So, that gives me 20, or y, sorry. That gives me y. Negative 15 over 20, you can get the lowest term by dividing both sides by 5, giving you negative 3 over 4 x. And negative 40 divided by 20 is negative 2. Okay, so negative 2. Because negative 40 divided by positive 20, that will give you negative answer. That is negative 2. So, our y-intercept here is negative 2. Unlike earlier, it is in positive 2. So, that is in negative 2. So, negative 2 is located here. 1, 2. Okay, that is here. And since our slope is the same as our first equation, negative 3 over 4, it means that we will go down 3 units. So, 1, 2, 3. Okay? And then we run 4 units. So, that is here. Okay. That is aligned to our 4. Okay. So, we will connect our points. So, basically, our graph is like this. This is for the first equation, and this is for the second equation. Now, as we can see, they did not intersect. They are parallel with each other. Therefore, the solution is no solution. And if it is no solution, meaning the nature of our system is inconsistent. Okay? Easy, right? Now, let us go to our final example. Okay, math learners, we are down to our final example. We have 6x plus 2y is equal to 10. And the second equation is y is equal to negative 3x plus 5. Now, as you can see in these two equations, the first one is already in its slope-intercept form. So what we can do is we can already graph our second equation. It is located at positive 5, the y-intercept. So that is 1, 2, 3, 4, 5. So that is here. And our slope is negative 3. Okay? What does negative 3 mean? It means that the numerator is negative 3 and the denominator is positive 1 because all whole numbers or integers has a denominator of 1. Now, this will be the rise and the run. Our rise is negative 3, so therefore we will go 3 units down. So that is here, 1, 2, 3. Okay? And then, we run once in the positive side. So that is here. Okay? So, 1, 2, 3, that is here. So, this will be our points. Now, we will connect the points to have our graph. And this is our graph looks like. Now, let us continue to our first equation. We have 6x plus 2y is equal to 10. What we can do here is we will transpose our first equation to its slope-intercept form. So, I will transpose the 6x. This will give me 2y is equal to negative 6x plus 10. And then, I will divide both sides by 2. Canceling the 2 here, giving me y. Negative 6 x divided by 2, that is negative 3x. 10 divided by 2, that is positive 5. Oops! As you can see, this equation and this equation are the same. Now, what does this mean? This means that our two equations are equivalent. Therefore, the graph will become identical. So, meaning, the graph of this first equation will also be like this. Now, what can we say about the solution? Since we have an identical graph, therefore, we have infinite solutions. And the nature of our system is consistent and dependent. Because consistent means it has at least one solution, and this is infinite, so it is acceptable to this nature. Dependent means it has infinite solutions. So therefore, the nature is consistent and dependent, and your graph is identical. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time learning about solving the system of linear equation by graphing method. Tune into our next discussion because I will discuss how to solve systems of linear equation using substitution method. This is still your free access math teacher Ash. And always remember, it is fun to learn mathematics if we are together learning. If you do have some inquiries about our topics, do not hesitate to put your comments or your inquiries in our comment section below. Thank you for your support. God bless and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.